Hello everyone, I'm Nika Yaznani. Today we're going to talk about the field of biomedical engineering. Well, I've prepared a brochure that I'm going to read for you to learn more about this field. In the name of God, biomedical engineering. Biomedical engineering aims to address medical needs by combining engineering sciences in the field of designing and maintaining equipment, as well as creating medical tools for application in disease prevention, diagnosis, and treatment. This field utilizes technical and engineering sciences to assist doctors in diagnosing and treating diseases. Okay everyone, we want to read this title together here, like History Biomedical Engineering, Objective of Biomedical Engineering, Biomedical Image Processing Specialization, and the fourth one is Rehabilitation Engineering Specialization, and another one is Modeling Trends in Physiological System and Trend in Precision Tools in Biomedical Engineering, and in the end we read Management Trend in medical information technology. Okay, so let's get started. Okay, we are going to read history of biomedical engineering. Before the 20th century, diagnosis and treatment during illness were based on examining the patient's condition, studying symptoms and related issues, and providing known methods such as prescribing medicine or performing certain surgical procedures. However, in the early 20th century, and particularly in the 30s and 40s, a new concept emerged in medicine viewing the human body structure as a highly coordinated engineering system, and disease as a disruption of this structure. Based on this concept, the field of biomedical engineering was founded, which focuses on studying the human body structure as a system, discovering physical laws and mathematical equations governing the system components, understanding the interactions, modeling this process, and investigating the impact of disease on this organized structure. The goal was to offer more effective diagnostic and treatment methods to improve disease. In biomedical engineering, the goal is to address medical needs in the field of equipment design, maintenance, and certain of medical tools for applications such as prevention, diagnosis, and treatment of disease by combining engineering sciences. This field utilizes technical and engineering sciences to assist doctors in diagnosing and treating diseases. Biomedical engineering is one of the newest fields that has taken a step into the world of the global technology, and it has been formed to assist doctors in diagnosis and treatment. Biomedical engineering has expanded accuracy and diversity in diagnosis to the extent that diagnosis without devices such as EEG, ECG, MRI, and CT scan is not possible. Devices have been developed in the field of medical engineering alongside diagnostic tools and therapeutic equipment, so that patients can receive treatment in a way that includes hearing aids, ventilators, dialysis, ultrasound or sonar, and various uses of lasers. Okay, a biomedical engineer in the initial stage performs operation, maintenances, and calibration of medical devices, and in more advanced stages can develop, upgrade, and improve medical devices, or even design and manufacture a device or artificial organ. In this field, due to the extensive innovation taking place, new branches of biomedical engineering are emerging, of which a brief description of the subcategories of this field has been mentioned. One of the other objectives is ligand receptor binding, which includes investigating and modeling the structure of cells and the process of tissue regeneration in damaged tissues in order to provide more optimal therapeutic methods for reducing and eliminating tissue damage, as well as producing artificial samples for their replacement. To this end, the causes and mechanisms of converting stem cells into various tissues and organs are examined, and using the models obtained, damaged tissues are repaired or produced artificially outside the body, include bone, cartilage, liver, pancreas, skin, and blood vessels. In this field, the data collocated on changes in the physical phenomena in the body are analyzed using electrical processing technology and high speed, and they present it in the form of the images. Often, this image can be obtained non-invasively without causing any pain for the patient. Biomedical image processing specialization. In this trend, image acquisition of static body components such as bones and tissues, and incorporating unique features of various imaging modalities for obtaining clear images such as 3D images, as well as presenting MRI and CT algorithms for processing tissue modeling and their lesions to provide more accurate and non-invasive diagnostic methods are being investigated. Also, the examination of physiology and dynamic tissue movement, functional imaging in the body, such as the heart and vessel, through functional imaging and modeling of the of these behaviors in healthy and unhealthy tissues in real-time methods are used for better detection of abnormalities and molecular imaging to investigate the location, structure and movement of molecules such as cancer cells, and justifying these movements based on statistical algorithms, as well as investigating and modeling various life mechanisms at the molecular level non-invasively for providing more accurate therapeutic methods such as designing antibodies and tracking them to better eliminate invasive molecules and cells and reduce damage to healthy cells of body. Rehabilitation engineering specialization. A new and developed a branch of medical engineering. Specialists in this field help improve the abilities and enhance the quality of life of individuals, and with advancements in technology, they assist in designing new gadgets and innovative methods for communication and residence. After the creation of the isometric force sensor device with biofeedback capability by Abul Faz Haji Hassan Khan, a revolution in this branch occurred because the quantitative expression of improvement in patients' condition was expressed. Modeling trends in physiological systems editing. In this field, an overall and comprehensive design of organism ranging from bacteria to humans is prepared using exciting laws in engineering, advanced methods, and necessary tools. In this field, computer modeling is used to analyze information obtained from experiments and formulate physiological details with mathematical relationship. Living systems have a highly regulated set of feedback mechanisms for self-control. One of the sciences that can be analyzed with modeling biological systems in the field of biomedical engineering with a new format is Eastern medical sciences, including traditional Iranian and Chinese medicine, which has not yet reached a wide range of parameters and may be rich in symbols and secrets due to its antiquity and has not corresponded with modern Western medicine. A trend in precision tools in biomedical engineering editing. The application of electronics in the diagnosis and examination of structures and diseases is practical in this trend. Computers are mainly responsible for this trend. Medical imaging systems are constructed by engineers in this field. Management trend in medical information technology editing. The Master of Science program in medical information technology as a new trend in the field of biomedical engineering has been proposed. The necessity of medical information in the field of medicine in the past decades has been one of the important justifications for information technology as a major applied field in recent decades. Given the rapid expansion of information technology, management in this field its importance has increased significantly. Medical information technology is now one of the important fields of information technology, and naturally managing information technology in this field is of great importance. Biomedical engineering courses. The most important courses in this field, which mastering them guarantees future employment and entry into the job market, are general mathematics, differential equations, general physics, computer programming, biostatistics and probability, numerical computations, statics and material mechanics in biomedical engineering, engineering mathematics, introduction to biomedical engineering, medical equipment in hospitals and medical clinics, electrical circuits, electronics, logical circuits, public health, principles of rehabilitation of tools and devices, principles and fundamentals of healthcare management, principles of radiology and radiotherapy systems, physiology, anatomy, medical physics, technical language of medical engineering, biophysics, internship, project.